Okay, on this one, I mean, it's the same idea. I'm just going to switch things around. A squared minus 4 over here because it's easier to go to the right to the left. And some people got confused. I'm not going to do this whole problem. I'm just saying some people got confused. They thought, oh, they saw difference of squares, they should factor it. Well, why would you not factor a squared minus 4 into a minus 2a plus 2?
Because it's easier to do it first and then factor.
Yeah, exactly. Because in this case, you're multiplying things out first, and then at the very end, if you can, you'll be able to factor. But okay, so this is a squared onto negative 2, and this one is, so it would be negative 4 onto 2a squared. And negative 4 into 3a. And negative 4 into negative 2. So that's 2a, a squared times 2a squared is 2a to the 4th. Then a squared times 3a is plus 3a cubed. This over here is negative 2a squared, and this is negative 8a squared, so that's going to be negative 10a squared. This is negative 12a. And negative 4 times negative 2 is plus 8. So we got negative 10a squared from a squared times negative 2, which is negative 2a squared, and negative 4 times 2a squared, which is negative 8a squared. You add these together, and you get negative 10a squared.
Okay.
Okay, so now on this question, what's slightly different than some of the other factoring questions we did? Like, you know, we'd get x squared minus 4, and we just go, well, let's factor it and get x minus 2x plus 2. And then we never really worried about anything after that. Why is this question slightly different?
Zero.
It's got an equals.
It's an equation.
That's right. Excellent observation. This is an equation. So let's go ahead and factor it, but bearing that in mind. So what method would we use to factor?
Well, you could get x quantity x minus 5 equals 0.
There you go. So x onto x minus 5. And it all equals 0. Now, are we done with this?
No.
No. X times x minus 5 equals 0 if and only if either x equals 0 or x minus 5 equals 0. So x equals 0 or x minus 5 equals 0. That means x equals 0 or x equals 5. And that's the final answer. Those are roots. If this were a drawing, this is a parabola, isn't it? That's a square. So we know that our roots are at 0 and 5. 1, 2, 3, 4, 5. And we know this is smiley face up because it's positive. We don't know where the vertex is, but if we wanted to, we could get it. Vertex is x equals negative. It's actually just negative b over 2a, where a is equal to a equals 1, b equals negative 5, and c equals 0. And this would be negative 5 over 2 times 1, and that equals positive 5 over 2.
Although they're not asking us to do that.
I know, they're not asking you to do this, but when we get it, we're going to look at this because you're going to need to know this. When we look at our t-chart and we put 5 over 2 in for x, okay, into there, we get, back to here, we got, hold on, we got x squared minus 5x, right? So we're going to put in, if f of x equals that, we're going to go 5 over 2 in squared minus 5 onto 5 over 2. This is all finding the vertex, guys. So this 5 over 2 squared is 10 over 4 minus 25 over 2 equals 10 over 4 minus 50 over 4, because we need to have the same common denominator. So we get negative 40 over 4, which is equal to negative 10. And in our t-chart, 5 over 2 gave us the output of negative 10, which we can find on a graph. This 5 over 2 is the same thing as saying 2 and 1/2. And that on a graph is 1, 2 1/2 up here, right? It's x is 2 1/2, and y is negative 10, so it's down here, somewhere down here. This is an approximate sketch. That's our vertex. Is it a smiley face up or a frown down?
It's a smiley face up.
Smiley face up. So in our axis of symmetry, okay, here's our chugga-lugga, all right? Okay, and that's the line x equals 5 over 2. The line x equals 5 over 2 is right there. That tells us, look at this. We've got our, oops, I actually made a mistake with the axis of symmetry. Oops, I'm sorry. I'm going to go back. Leave the camera on. So going right here. 5 over 2 is 1, 2 1/2, and then negative 10, somewhere down here. Okay? That's our vertex. Is 5 over 2 and negative 10. Now, we've got two roots, we've got a vertex, and we know it's a smiley face up. We've got almost everything we need to draw this parabola except for one thing, and that's the axis of symmetry, which is x equals 5 over 2, which is just the x coordinate that we've already discovered when we go negative b over 2a. And that's at 2.5, we draw a line right on through there, and that is the line x equals 5 over 2. It's our axis of symmetry, and it cuts the parabola in half. And that's exactly what we're going to do when we graph this thing. All right, and we're going to be a little more careful about it. We've drawn it, we've set it up so nicely, we wouldn't want to, okay, spoil it with a messy drawing. And then this way, right through 0. And that's our parabola facing up, smiley face, yes, two roots at 0 and 5, because that's where the parabola crosses the x-axis. That's where we get our solutions, our real solutions, real number solutions. Guess what? The x-axis is the number line. Remember when we did conjunctions and disjunctions? It all ties in now, guys. That's the number line that we were working with. But that was only one dimension. This is 2. And when you do calculus 3, you'll be going into a third dimension where you'll be integrating regions. And yes,
who uses
third
this
dimension.
stuff?
Engineers, people who design bridges, stores,
Mr.
schools, cars.
This has nothing.
I know. But hey, if you want to be an actress, you need to know the third dimension, and you need to know the fourth and fifth too. But you need to know 3 dimensions. You do.
I just need to learn lines, Mr. Day.
Do lines not have more than one dimension? She says, I want to be an actress. I want to learn my lines. That's all I need to know. I'm saying lines have more than one dimension. It's not just learning a line. It's what you put into it. It's the expression. The emotion. What is behind the line? It's Hamlet with a skull.
What?
What if that's your job?
Action!
Nice. 2x squared plus 7x equals 15. We need to solve this. How do we do it?
15.
That's
so
for sure.
0, it's an equation.
Okay. Yeah, we want to make an equation equal to 0. So it's 2x squared plus 7x minus 15 equals 0. Now, what do we do now, guys? Because it doesn't look like it's too easy to factor. What do you think we should do?
Oh!
Or maybe we can. What method would we use?
Oh!
Yes.
The swing method.
Let's try it. We've got
Okay,
x squared, quiet guys, plus 7x minus 30. Don't forget you're going to divide that 2 back out in here. Factors of 30 are 30 and 1, 15 and 2, 10 and 3. There's lots of
I
them.
think 10 and 3 is not a good
You think so? 10 minus 3 is 7. You got it. 10 minus 3 is equal to positive 7. We'll use those. I think that's a great idea. Now, don't forget about that 2 up there. He's still lurking in the shadows. X plus 10. X minus 3. Now, he comes back and pounces underneath the 10, underneath the 3, and we end up with x plus 5. And this is 2x minus 3. All of it, don't forget, all of these little things we cannot forget. This is all equal to 0, see? And now, this can only be equal to, this can only be true if either this are true or that is true.
So x equals negative 5.
So it's x, well, you're jumping ahead of us again there, Caroline. X plus 5 or 2x minus 3 equals 0. Either x plus 5 equals 0 or
3 over
2x minus 3 equals 0. Now we have to solve those, which Caroline just did, but that's okay. X is equal to negative 5 or this. Go ahead, Caroline.
It's either that or
3 over 2.
Yes. Good.
Sorry. I kind of...
You just could not resist.
I had to say it.
Okay, so these are your 2 solutions, and again,
None of them equal 0.
here, the thing is, if we put negative 5 in for x, guess what? This whole thing would equal 0, and that times that would equal 0, because this times that, if this is 0, if x plus 5 is 0, if this whole thing were 0, then 0 times anything would equal 0. So that's why we're finding the number for the value for x, which is equal to whatever it is, to make this 0. Good question again. And it's again here. If this were 3 over 2, this 2's would cancel, we'd have 3 minus 3, and this whole thing would become 0, and 0 times that would be that. Nice clarification.